Hello everyone. In this video, I am going to teach you recurrence relation problems by using generating functions. In the previous video, we learned about the process of solving recurrence relations by using generating functions. Please watch that video to understand the process of solving recurrence relations by using generating functions, because we completely depend upon the problems of recurrence relations solutions by using generating functions on that only. So before we start the problem of recurrence relation, we need to recall the topic of partial fractions. We know about the partial fractions in lower classes. We have three methods basically in partial fraction decomposition. If the fraction of the form 1 by ax plus b into cx plus d means the denominator, depending on the denominator values, we will write the partial fraction decomposition. Okay. Here in this fraction, the denominator has two different factors. In this case, we will write the partial fraction as a by ax plus b plus b by cx plus d. Here a comma b are unknown constants. And second method is, if the denominator is of the form repeated linear factors. In this case, we will write the partial fraction as a by ax plus b plus b by ax plus b whole square. Here a comma b are unknown constants. And third method is, if the denominator has the polynomial of second degree. In this case, we will write the partial fraction as ax plus b by ax square plus b. Here a comma b are unknown constants. Now, let's start with the problem. Here, solve the recurrence relation an is equals to 8an minus 1 plus 10 power n minus 1 with the given value a1 equals to 9. Solve this recurrence relation by using generating function method. Now, solution. Given recurrence relation can be take as equation 1. Now, we have the procedure in our previous video. Depending on the procedure of solution of generating functions by using generating function, we need to solve this problem. Now start with the first step as let we take the generating function name g of x is equals to summation n equals to 0 to infinity an x power n. This is the general form of the generating function. Okay, so take it as equation number 2. Now, the given recurrence relation can be solved by using generating function means we can convert the given recurrence relation in generating functions form only. That's why the given recurrence relation can be converted into generating function by multiplying the summation part and x part to the given equation. Okay. So now the first step is take summation means sigma from n equals to 1 to infinity on both sides of equation number 1 and multiply x power n on both sides of equation number 1. That's why equation 1 can be converted as like this: an x power n equals to 8 into 8 means some here this is constant, that's why we take outside of the summation. N equals to 1 to infinity a n minus 1 x power n plus summation n equals to 1 to infinity 10 power n minus 1 into x power n. Okay, so to get a general form of the given recurrence relation, we need to convert this term as, here observe the generative function here, it starts from 0 to infinity an x power n summation. So in place of summation n equals to 0 to infinity an x power n, we write g of x as generative function. But here summation n equals to 1 to infinity an x power n is there. That's why from equation number 2, here we are going to write this term in generative function form as g of x minus a naught. Why? Because here there is no first term, means constant term. That's why from equation number 2, the first term is missing in this case. So that's why it can be written as g of x minus a naught is equals to 8 into summation, observe carefully in every term, n equals to 1 to infinity, here a suffix value is n minus 1, x power value is n. So take care of the suffix value of a and power value of a, both are same. So we are going to equal of these two, multiply x and divide x to get x power n minus 1. So we are multiply x a n minus 1 x power n minus 1. Okay, less. Similarly here n minus 1 is there, but here n is there. So to convert n as n minus 1, we multiply x and divide x. N equals to 1 to infinity 10 power n minus 1 into x power n minus 1. Okay. Now g of x minus a naught equals to 8 into the summation can also be written as n equals to 0 to infinity an x power n plus summation n equals to 0 to infinity here x into 10 power n x power n, because this summation and the summation in the above step are both are equal. So now here g of x minus a naught value is given, a1 value is 9. So put n equals to 1 in the given recurrence relation, then we get the value a naught equals to 1. Okay, please check it. Substitute n equals to 1 in the given recurrence relation, means equation number 1, then we get the value of a naught equals to 1. That's why here minus 1 is equals to 8 into this sum can be written as the generative function of name as g of x plus x into, this is the generating function standard form, already we learned in the first video of the generating function, that is, which is of the form 1 minus ax whole power minus 1. Okay, So here, which is of the form 1 by 1 minus ax form, it can be written as 1 minus ax whole power minus 1. So from this, g of x minus 8x into g of x plus is equals to x into 1 minus 10x whole power minus 1 can be written as x by 1 minus 10x plus 1. So minus 1 can be taken to this side. Now g of x value is 1 minus 8x is equals to, here LCM is 1 minus 10x. So x plus 1 minus 10x. So this is 1 minus 9x by 1 minus 10x. Now g of x value is, 1 minus 9x by 1 minus 10x into now 1 minus 8x can be taken into right side value, that is 1 minus 8x. So this is the value of g of x. Now g of x can be decomposition into partial fractions. So this fraction can be decomposition by using partial fraction as a by 1 minus 10x plus b by 1 minus 8x. Now here a comma b are unknown constant. A comma b are can be solved by using the partial fractions. So we know about the partial fractions problems. So here after using the partial fraction method, we have the values of a equals to 1 by 2 and b equals to 1 by 2. Now g of x can be rewritten as 1 by 2 by 1 minus 10x plus 1 by 2 by 1 minus 8x. Okay. Now g of x is equals to 1 by 2 into 1 by 2 into 1 minus 10x whole power minus 1 plus 1 by 2 into 1 minus 8x whole power minus 1. Now g of x can also be written as summation form, that is summation n equals to 0 to infinity an x power n equals to 1 by 2. This is the standard form of generating function. So that is 1 minus ax whole power n form, that is summation n equals to 0 to infinity 10 power n x power n can also be written. And similarly 1 by 2 summation n equals to 0 to infinity 8 power n x power n. We have standard form of the generative function in the first video of the generative functions. So now equating a in terms on both sides. Now an equals to 1 by 2 into 10 power n plus 8 power n is the solution of the given recurrence relation by using generative function case. Okay, thank you.